This is T. Bhargav from Mechanical Engineering, SIT College, Anantapur. Today, our discussing on frequency of longitudinal vibrations in theory of missions. Let us move on. Frequency of longitudinal vibrations. Introduction to longitudinal vibrations. Let us see first this image. This is displacement wave from source, and this direction of transfer of energy, and displacement towards source. This direction distance from source. Longitudinal vibrations refers to oscillations that occur in the direction of the wave propagation. These vibrations are commonly observed in solids, liquids, and gases. These are mainly observed in solid, liquids, and gases. Understanding the frequency of these vibrations is crucial for various applications in engineering and physics. Basics of vibrations. Now we can discuss about basics of vibrations. Vibrations occurs when object oscillates around the equilibrium position. The frequency of vibration is defined as the number of cycles per second measured in hertz. So, the frequency of vibration is defined as number of cycles per second measured in hertz. This is measured in hertz, and longitudinal vibrations especially involved compressions and refractions along the medium. Characteristics of longitudinal waves. Now we can discuss about characteristics of longitudinal wave. Longitudinal waves consist of areas of compression and rarefaction within the medium. The particles of the medium move parallel to direction of wave propagation, and this type of wave is essential for understanding sound transmission in different materials. Like this diagram, briefly observe this diagram. We can understand clear in the slide. The frequency equation. Now we can see the frequency equation in this slide. The frequency f of longitudinal vibration can be calculated using the formula f is equals to v by delta. This is the formula for using longitudinal vibration. Here v represents the wave speed and delta is the wavelength of wave. Understanding this equation helps to predicting how sound waves behave in various environments, like this one. These are the diagram seeing W is equals to mg and W is equals to s delta. This region is called delta. It is a frequency formula. F is equals to v by delta. Speed of sound in different media. Now we can observe what is the speed of sound in different media. The sound of wave. The speed of sound varies depending on medium through which it travels. In solids, sound travels faster due to the close proximity of particles. Liquids and gases transmit sound at a slower speed, which affects the frequency of longitudinal waves. Here also have some. The speed of sound varies depending on media. So these are the sound speed according to medium. Air speed is this one, 1100, and water is 4900. Steel is 16400. It has a speed of sound. Factors affecting frequency. Several factors influence the influence the frequency of longitudinal vibrations, including the medium's density and elasticity. Temperature also plays a significant role, essentially in gases where increased temperature can raise the sound speed. Understanding these factors is essential for applications in acoustics and material science. This stable frequency. The difference between stable frequency and unstable frequency means unstable frequency there is a uniform frequency, there is a fluctuations in frequency. And applications of longitudinal vibrations. Applications of longitudinal vibrations is longitudinal vibrations are crucial in various fields including engineering and seismology and audio technology. They are utilized in ultrasound technology for medical imaging and diagnostics. Additionally, understanding these vibrations will help improve sound quality in musical instruments. Measuring frequency. Now we can see how to measure frequency. Frequency can measured using various instruments like oscilloscopes and frequency analyzers. Techniques like Fourier analysis can dissect complex waveforms into their constituent frequencies. Accurate measurement it is virtual for research and practical applications in acoustics. This is the device to measure the frequency. Longitudinal vibrations in nature. Longitudinal vibrations are prevalent in natural phenomena such as earthquakes and sound wavelengths from animals. The study of these vibrations help scientists understand geological activities and animal communication. This also helps for animal communications and geological activities. Observations of these waves are critical for developing warning systems and conservation efforts. This is a wave in nature. This is the called wavelength and this is the sound pressure. Challenges in studying longitudinal vibrations. Researchers face challenges in oscillating longitudinal vibrations from other types of vibrations. Environmental factors can introduce noise that complicates frequency measurements. Advanced techniques are required to accurately analyze the and interpret longitudinal wave behavior. And these are the additional matter to understand briefly about challenges studying longitudinal vibrations. Future research and directors. And future research directions is ongoing research aims to enhance our understanding of longitudinal vibrations in complex materials, investigating the effects of nanostructures and wave propagation is a correct area of interact. Future studies may lead to new technologies in sound manipulation and material design. These are summary key points. These are the summary of longitudinal vibrations. Longitudinal vibrations play a vital role in various applications including acoustics and engineering. Engineering also plays a crucial role. The frequency of these vibrations is influenced by medium properties and environmental conditions. Understanding and measuring longitudinal vibrations is essentially technological advancements. Questions and discussions. These are the questions and decision. Thank you for your attention. Are there any questions regarding the frequency, longitudinal vibration? I encourage decision and how these principles apply to your fields of interest. Let's explore my specific examples you may encourage in practice. And at last I want to tell that the longitudinal vibrations is essentially for all and study everyone, because it is very important where the vibrations are react and how they are. It is helps to communication in animals and to detect earthquakes and wavelength of in nature. And these are the my slides. Thank you for giving this wonderful opportunity.